Alright everybody, here is the graph that you were supposed to have produced for the homework, Unit 3, Worksheet 1, dealing with uniform acceleration. So, I plotted the graph, as you can see here. I scaled the graph so that I went by ones over here. So 1, 2, 3, 4, 5, 6, as you can count. I went by fives on the vertical axis for the velocity. So 5, 10, 15, 20, 25, 30, and so on and so on. So, notice I've also labeled time and velocity on the appropriate axes, and I've also, in parentheses, included the units of measure for those variables. Make sure that you do that on your graphs. So once I got the points plotted, I used a straight edge, or at least as best I could, and I drew my best fit, as you can see on the graph here, following my data points as best I could. So it looks like I grazed most of them. I just missed this one a little bit, but I think it'll be all right. So at this point, with your homework, you were supposed to find the slope of this graph. Well, if I'm looking for places to find slope with, remember we used 2 points to find slope. So I think this one looks pretty good right here. And this one looks pretty good down here. So here's what I'm going to do. I'm going to mark that right there. That's 1 point I'm going to use. And this is another point I'm going to use. So what I need to find now is the rise and the run of that section of the graph. This right here is my rise. And if you notice here, I'm starting from 10 miles per hour, and it goes up to 50 miles per hour. So from 10 to 50 is what? A rise of 40 miles per hour. And then I've also got my run down here, and my run starts at 2, that's 2 seconds, and goes over to 10 seconds. So my run then is 8 seconds. Now, what do I do with that? Well, hopefully you remember. You take your rise over your run. And so my slope over here is the rise over the run. And in this case, I want you to think about this. The rise is how much the velocity changed. The velocity changed by how much? By 40 miles per hour. So that's my change in velocity, delta V. Remember that. And down here, my run is how much the time changed in seconds. And I changed 8 seconds in this little interval that I'm looking at. And so that is a delta, or a change in time. So remember, that's what we're finding here. That's what this slope is. It's a change in velocity over, or divided by, the change in time. So if we put some numbers in here, that's 40 miles per hour, delta V, divided by 8 seconds, which is, last I checked, 5 miles per hour for every second. Now, the next question on this worksheet was, what does that mean? What does this slope represent? And I hope you are remembering that this slope, the change in velocity over change in time, anytime your velocity is changing, we call that something. I hope you're thinking the word I'm thinking. It is acceleration. So remember, the slope of this graph is the acceleration. Now, how does this mean acceleration? Well, think about it. If your velocity is changing by how much? By 5 miles per hour. And how often is that happening? Well, it's happening every second. So after 1 second, if you started from rest from 0 miles per hour, then how fast would you be? Again, after 1 second. Well, after 1 second, you would be 5 miles per hour. That's in 1 second. After 2 seconds, how fast would you be? Add another 5 miles per hour. So you'd be 10 total after 2 seconds. After 3 seconds, how fast would you be? Another 3 seconds goes by, and you would be 15 miles per hour. And that's after 3 seconds. So I hope you're seeing and realizing what's happening here. This is telling us how much faster, how much velocity changes for every unit of time that goes by. So every second, we're just going to keep getting faster and faster and faster. By how much? By 5 miles per hour every second. So that's what the meaning of this slope is. That's what it represents. Now, next part, you're supposed to draw a motion map. Okay, so I will draw a motion map up here, marking my 0. Oh boy, that's just about off the screen. Marking my positive direction. Boy, this is not looking good. And think about what's happening. If you look at this VT graph, how much velocity does this object have at the start? None. That's 0, which I probably should have marked. That's 0 over here. So if that is 0 velocity, and this is a steady increase of velocity, then that means my arrows are going to be starting, hopefully you're thinking small, 0, and they're going to be getting bigger because the velocity is getting bigger. So I guess the next question is, though, because remember, we always have to answer the 3 questions. Where does it start? What direction is it going? And what do you know about the velocity? Well, do we know where it's starting? Do we have any idea where the object is starting on the motion map here, judging by what this graph says? Well, I hope you're also remembering, what can't a velocity time graph tell us? I hope you were thinking position, because the velocity time graph cannot tell us position, so we have to make that part up. So in other words, on your motion map, you can put anywhere you want here. So I'm just going to start right here because I can. If you want to start on the origin, then start on the origin. But it's going to be, oh boy, this is tough on this little whiteboard here. Oh boy. The arrows, as you can see, although not the prettiest in the world, they are definitely getting longer. In what direction? The positive direction, because these are all positive velocities, and that line is increasing positively on this graph. Now the next question then on the motion map is, what direction is the acceleration vector? So when you draw the acceleration vector on this, which way should it be pointing? I hope you're already thinking, and I hope you have it correct on in your comp books, I hope you're thinking to the right, for 2 reasons. Remember, the velocity arrows are getting longer to the right, to the positive. So the acceleration has to be also in the positive direction. Also, if you look at this graph right here, this slope is positive, which means your acceleration has to be positive. So speeding up in the positive direction means acceleration in the positive direction. Okay, and what is a description of this motion in words? How would you describe this motion in words? Well, here's what I would describe it. Here's how I would describe it. Oh, let's see. We don't know where the object starts. So you can't say that. You can't use starting position because we don't know what it is. What we do know is that it is accelerating. and it's traveling in the positive direction and getting faster in the positive direction. So how are you going to word that? Well, let's see. Object. Oh, this is going to be ugly. Travels in the positive. I'm just going to use plus because this little stylus is not working very well. Object travels in the positive direction wow, this is terrible. In the positive direction with I should have just drawn a plus sign, with a positive acceleration. So it's speeding up. So there you go. I suppose that would be a good enough description for what we see here. Okay, and the last thing, you need to write the equation. Well, by equation, what am I talking about? Well, I hope you remember that we're talking about the y equals mx plus b. That's it. And I hope you're also thinking that the y is not the y-intercept. The y is the y variable. M is the slope. How steep is this? X is the x variable, and b is the y-intercept, which in this case, we look here, oh look at that, it hits the origin, so the y-intercept is actually 0 in this case. So if I'm going to write out this equation here, full equation with words and numbers and units on every number, then we'll start with velocity, since that is the y variable. Velocity equals, and what's my slope? Well, we found that over here. So my m is my slope. That's 5 miles per hour for every second. I'll put that in parentheses. And then beside that, again, we have the x variable, which is time. So that's the slope times time plus, and what do we have for a y-intercept? Again, we said 0. So I'm going to go ahead and write it in there, even though I suppose you don't really need to. Now, if this were something besides 0, what would be the unit of measure on that y-intercept? Well, again, you look over to the y-axis, and it's velocity measured in miles per hour. So it'd be 0 miles per hour. So there you have it. Hope that made some sense.